Hello, are we live? Hopefully we are live. Hopefully we And you can hear me. We're live. Hello everybody. Welcome to the stream. The stream is now. And we have some stuff to get to. Welcome everybody. Let's make our little announcement on Discord. And we're doing compiler work once again. Part 33. No, 23. Notifs, please. Nope, notifs, please. Thank you. Alrighty. Perfect. The notification is out to all of you lovely people in the Discord. Speaking of which, there was a pull request. So we're gonna have to take a look at this pull request on stream. There's a pull request to the compiler. That's right. Which is incredible. I'm so excited that one of you lovely viewers has decided to check it out. So rnow478 actually made a pull request. Let me see if I can get this in a bit of a different thing. Yep. Sorry, just doing some management over on my second monitor, trying to get my thing working. Okay, I think I'm ready. And as you can see, there's a secret command line flag. Perfect. So there's a -- aluminium flag that does some magic. So if we, I don't, Yoshi Boy 18303 says, I'm here now. How's it going, Yoshi Boy? What's up? I'm streaming. We're doing more compiler work, and there's actually been a pull request. So we're probably going to merge this thing. And if we take a look at the files changed, we see that all that's changed. Let's take a look in Emacs. So let's find programming, Streama 2022, fun compiler. Source main.c is what was altered. Line 89, it looks like. So you can see that instead of else here, this else, Yoshiboy18303 says, the ceiling is up, plus I'm working in C#. That's fair, the ceiling is up. We are both inside. You're working in C#, that's awesome. Are you making a game? Are you making a server, like model view controller type thing? What are you working on? Just programs? Command line programs? As for this pull request, we can see that it basically says our little matching. So it says if string compare argument -- aluminium, and it says equals 0, so we're good there. We do have a bit of a code style issue, but I'm not going to be a stickler. We'll accept it even though there should be a space here. We can fix it. Yoshiboy18303 says, I'm just making a Discord bot, currently working on using Lava Link using the Lava Link for Net wrapper. Yikes, that's over my head. That's really cool. What kind of Discord bot? What's the plan for it? Also, sorry, that might have been super loud. Just switching positions. Fix me must test this. So, Lamau. So, yeah, I guess all I have to do is get my working tree able to take this in, which I think it should. Yoshiboy says it's a learning project for me. That's incredible. That's a very impressive learning project. Okay. I don't have main.c touched, which I think is a good thing. So what I am going to do is try and pull this pull request, right? And try and build and run it and see if it works. That's the thing to do, right? So, oh man. Oh man. I mean, I could just merge it and fix it as we go, but I want to test it first. Okay, where are we at? I have to go here. Yes, it is. So do I clone this entire thing into a new... I'm not experienced on how to accept, like, test other people's pull requests. Can I just take this branch, or do I have to actually... It's not a different branch, it's main branch. So this isn't a branch merge, this is a fork merge, which means that I just have to, yeah, give me the thing. That thing. Okay, we'll go here. So we are going to navigate to... Let's just do... Yeah, this is fine. Does anybody remember how to tell Git where to output a file when you're cloning? Is it git help clone? I never remember. Yes, it is. Okay, what do we got? I know there's a way, and you're gonna tell me. -o name? Use... Yeah, I don't want to use origin. I'd like to change where it... where it goes to, the directory. Do I just add the directory after? The name of the new directory to clone into. It says directory, so I just add the directory. Yeah. So at the very end, add the directory I want to clone into. Alrighty. So I'd like to run a shell command. We're going to git clone... where is it? I need it again. Thank you. But that's really cool to hear, Yoshi boy. Be sure to keep us updated, because I am very curious. And this is going to be fun compiler aluminium. Oh god. Aluminium. There we go. Perfect. Perfect. So now we can enter here and do a little Cmake Generation. So we're just going to say -d build. I think that's all we need to do for this one. I could make it like -d Cmake build type equals release, but I don't really care for that right now. It's for Visual Studio. I don't want that. So we're going to remove this folder. Thank you. And we're going to remember that we are on Windows and set a new generator. So let's use like Ninja so that I can use GNU toolchain. Yes, thank you. So now I need to build that build tree like this. Perfect. And now I should have build/func. Perfect. This is our compiler. It still builds, it still runs. That's a good sign. So let's make sure that our little special flag works, right? So --aluminium into our... Ooh, that's not how you spell that. There we go. Eternal Wild Fox, good afternoon. How are you doing? I'm doing okay. I just woke up. It's the morning for me. I hope you have had a good day. And we are actually going over a pull request made to the fun compiler. It's a very simple one, so it's looking like it's going to be merged. And we're just about to do our first test. Are you ready? We're going to test it. Yeah. Yeah. Oh yeah. Gotta get that. Non-copyright. So I gotta talk over the song. Oh yeah, baby. That was good. That worked better than expected. Oh, that was so good. So we definitely have it working on Windows. It's not a fix me. Oh, what a great pull request. What a great pull request. This is getting merged. Oh, woo. That's fun. That is very fun. A little bit of Rick Astley. It works. Eat the works. Defined win32 underscore win32 underscore underscore win32 underscore underscore or NT. You really checked everything. I'm pretty sure you just need this one. It's all good. Or Linux or Unix? Yeah. This looks like it'll work. Watch OS. We're definitely gonna be running the fun compiler on Watch OS. Oh, that was fun. This is fun. Eternal Wild Fox says, I'm still trying to get the Prat parser going. Oh my god. Yeah. It looked like you had it with the multiplication coming first. Maybe I need some pseudocode. Okay. Yeah, I can do that. Let's merge let's merge this pull request first. Also, I can't click on anything anymore. Hello? There we go. That was weird. So I would like to create a merge commit. I think instead of like being semantic and making him change things, I'm just gonna merge it and then fix it in the next commit with the little code style change and then the fix me because we have tested it. Oh, again. Yep, not allowed. Okay, gotta go to commits first, then conversation. So there's a bug in Git, in GitHub, not Git. I can request a review from myself. Self-requested a review. Okay. I don't know what that did. Now I know. I'm looking at it. uh, it's so good. Everything looks good. I think that wasn't necessary, but it's cool that I can do that. I can request myself. Eternal Wild Fox says, I also tried with that Ruby code, but I don't understand the syntax, lol. Yeah, I don't understand Ruby that much either. I don't have experience with it, but just everything about it seemed like the right thing to do. So this is going to be, yeah, we'll just leave it like this. Why not? Secret command line flag. Sure. Sure. Yeah, we've accepted a pull request. More than one person has worked on Fun Compiler now. Look at that. Arnow is now a contributor. Yay! So good. So let's go back to our original Fun Compiler. And let's do a Control-X-G to get our Git going. And I think I need to fetch. I believe I need to fetch. How do I do that? I'm not often fetching. That's a lower F. I'd like to fetch from all remotes. I'm sure we only have the one. Perfect. So now we can we can pull from origin main, and it'll fast forward merge us right up to here. So now look at that. Origin main and my main are both on the same merge pull request. Hooray. And this is already pushed because I pulled it. So yeah, we have a bit of a plan for today. Other than that, we can remove this fix me. We tested it. And yeah, this is beautiful. I like the conditional compilation. I kind of want to get rid of everything we don't need. But, why not? Having more tests isn't a problem. I think I'm going to do this as well. I feel like that's a bit more readable. You're like, else if this, if defined when Windows, instead of like having to go all the way to the left for no reason. We'll try it. We'll try it out, and then the code style change with the curly brace. I think that's pretty good, or I could do something like this. Also, why are these indented and these not? It's a little confusing. Interesting. So, so when I indent these, they go there, but when I indent this, it stays there. Okay. I think this is easier to understand in any case. Or not, and I'm dumb. Mr. Mugume, how's it going? Thank you so much for tuning in. Ryzen 7000 got announced, lol. New CPUs, that's good. Alright, well with this pull request accepted, let's Eternal Wild Fox. Yes, Eternal Wild Fox needs help session 5. So let's do Pratt parsing pseudocode. Or something like that, right? And what dot pseudocode? I don't know, it doesn't matter. So the idea with Pratt parsing is that we have some table. So, and this is like our precedence table, right? Or mappings or whatever. So you're gonna need like some operator mapped to precedences. I think you're good at, like, you have this down. When you're done with the pseudocode, can you place it on Discord? 100%. So you have something like this, where multiply and divide have a higher precedence than plus and minus. Let's say, right? And these are a binary operator precedence table, right? Mr. Mugume says, if the prices don't go to the moon, I'll probably get one. My 3060 Ti is a little bottlenecked by my 2600X. Oof. Oof, Mr. Mugume, way to flex. Way to flex. Eternal Wild Fox says, right. Alright, you get this. So now let's give some input and turn it into tokens. So if we have the classic, like 2 times 3 plus 1, if you're just parsing this, a naive parser would go, okay, also let's think about tokens. If you want, we can, like, this is what the lexer would spit out, right? These are our tokens. So we'd start parsing and look at our first token and say, hey, that looks awful lot like an integer. So you'd create some sort of integer node, right? Mr. Mugume says, talking about moon, did that rocket launch? What? I'm sure they did. There's rockets, so many rockets. Rohan says, good evening. How's it going, Rohan? It is so good to see you. Thank you for tuning in. Right now we are writing some pseudocode to help out Eternal Wild Fox with Pratt parsing. But just beforehand, we have merged a pull request, the first ever pull request that opens a YouTube link when giving a command line flag. So you'll have to try this yourself and see what happens. Or look back in the VOD, because we did it. Mr. Mugume says, that's not just some rocket, it's the first launch of the next rocket going to the moon. I don't know why people get excited about that. It's just a rock. It's a big empty rock in space. And it's not useful. I mean, the best thing we could hope for is, like, there's a bunch of iron or like material or gold. Like there's not. The moon is just boring. I'm not sure why people want to go there. But I get it. It's cool. We don't go to the moon all the time, so why not go? Rohan says, so error 5 still doesn't rickroll you? Sag. Lamau. Sed Pepe. Eternal Wildfox says, right, the parser makes an integer node. I'm so sorry, Eternal. I'm getting sidetracked with chat. So we have an integer node. And then we go, okay, this is our result, right? So let's call this our result. And into result, we wrote an integer. And then we look ahead for binary operator after parsing anything, right? So every time we parse something, we look ahead for a binary operator before we're finished parsing. So we looked at 2, we got integer, now we look ahead for binary operator. We find multiply, right? We'll just do this. Find multiply and effectively get precedence, right? So you want to basically get like current precedence equals precedence of, and then you'd be like multiply or whatever you have here, right? You could do something like that. Access your table, get your precedence. While parsing, you have this like working precedence. So we're just gonna call this working. Ooh, what just happened? I don't know what just happened. I alt-tabbed for some reason. Working precedence. And working precedence starts at the lowest, below every single operator. So it starts at 0. And you basically say, okay, if current precedence is less than or equal to the working precedence, do something. So instead of taking our result, right? So this integer node, wherever we parsed into, we're going to call that result, right? And this result, we would say, well, either way, we're going to have to create a binary operator node, right? Because we found one. We found multiply. So with its precedence, then what we're going to do is say, okay, let's create our binop node, new node or whatever, right? I don't know what that would be, but you create a new node. You set its type to binary operator, right? So now we have to deal with what the children are. And the idea is multiply. Our current precedence is 2, so it's going to be greater than our working precedence. So we're not going to go down this path. We're going to go down the else, and the else is basically going to say, okay, perfect. The else is basically just going to say, put the result on the left-hand side. So left-hand side of binop node, we'll set that to result. Continue to parse into right-hand side. Does that kind of make sense? I'm pretty sure that's what we're doing. Well, let's see. Let's look at my parser, because I don't want to lead you wrong. Let's look at fun compiler, source, parser. And basically, binary operator. Yeah. So, yeah, basically copy the whole thing or copy the last thing. So effectively, we continue to parse into right-hand side. Right-hand side, because we're parsing into it, becomes our working result. Oop. We'll do this. Becomes our working result, right? This is also a terrible mix of like English and pseudocode, so I'm sorry. But basically, we have this binary operator node, and we have to decide where it goes in our AST. Where does the left-hand side and right-hand side, like what are they actually set to? Because we know we're going to have this binary operator node that's like a multiply, right? So the idea is with our current precedence being less than or equal to our working precedence, that would mean that, oh, by the way, update working precedence to current precedence at the end. That way next time you go around, it works. But yeah, basically, our integer, the thing we started parsing at the very beginning, is result. And the thing that we're parsing into is working result. So the idea is, at the very beginning, we're parsing into a singular node. So it's result and working result are both integer. Whereas when we parse the right-hand side, we have now parsed the left-hand side, we've parsed this binop node, and we are parsing the right-hand side now. So this becomes our working result, and our whole result gets updated to our binary operator node. Does that make sense? So effectively you say, set the left-hand side of binop node to result, then you set result to binop node. Then we continue to parse into right-hand side. Eternal Wild Fox says, yay, I think so. Awesome. Continue to parse into right-hand side. Right-hand side, because we're parsing into it, becomes working result. So then, next time around, let's say we get another integer, which is our working result, right? It would be 3. We look ahead for a binary operator, we get plus. We would get the precedence, which would be 2. And 2 would be less than or equal to working precedence 4. So because our working precedence is updated to our previous current precedence, which was the multiply. So with 2 less than 4, what we need to do is place the new node that we create in the left-hand side. So left-hand side to result. We actually need to do this. It's fine. So basically we have our current precedence, and when our current precedence is less than or equal to our working precedence, then we use the result, otherwise just the working result. So this would be working result here, is what I should say. And then here is where we should actually do our little result trick. And then I think this is true no matter what. So basically, when you're going, the working result, you update all the time to what you're actually parsing. So when you parse an integer, like 3, that will always be your working result because that's what you just parsed, if that makes sense. So there's a difference between like the whole thing, the whole tree that you're parsing, right? Because result at the end needs to be a tree that looks something like this, with plus going to 2 different directions of, what would it be? It would be multiply on the left-hand side. Yeah, because we want to do a plus after we do a multiply. We want plus on the very top with 2 times 3 on the left and 1 on the right. So this would be a 1, and then we'd end up with something like that. Not needing an AST tree, I'm generating bytecode. Well, you'll still need an AST to generate the bytecode from, otherwise you'll do it in the wrong order. Or you need to like recursively generate bytecode instead of generate a node. But it's easier to generate an AST and then generate bytecode from that in a code gen step. It'd be hard to just like generate bytecode from this, in my opinion. Like to go from tokens to bytecode would be kind of insane. Because how would you get the semantics of like, oh, the plus goes first? You'd have to parse forwards, reach the plus, you'd go, okay, we have to do that last. Like, it wouldn't be helpful, right? It'd be an insanely hard algorithm. You'd have to like look ahead and then go backward to where you started parsing, and then keep looking ahead until you get back to where you were, and then continue forward for the right. It'd be so complicated. But you do need an AST to generate bytecode. Otherwise, you'll do it in the wrong order. It'd be very difficult to understand the semantics of math without a tree, right? So this will be 2 and 3. So you need to generate this tree. If you're generating bytecode, then you just need to figure out what this would change. If your bytecode has like a result and a working result, then you can just use those as registers or whatever. Eternal Wild Fox says, I more or less tried that last on paper. Okie doke, okie doke. But yeah, so if you're going to generate bytecode, then instead of creating a binop node, you'd have to like create a parser stack. So you'd have to create a stack that you can return to or make a recursive call, or it would be really complicated. Or there's a simple way to do it that I just don't know how. But once you have this, it's really easy, because all you do is go like, okay, you have result node, you say while result, you basically just have like gen bytecode, right? Which takes in a node. And then you can just say for all children, called child, gen bytecode, node, child, right? And you just gen bytecode for the node, which generally turns into like a switch case, or if node is integer, do thing, elif, blah blah blah. Node is binop, do other thing. I believe it is possible to go from tokens to bytecode. Oh, it's possible. It's just not worth it. It's making your life a lot harder than it needs to be. Because the problem of prat parsing works on ASTs, really, or things with working results. So like in your bytecode, if you have, remember I was looking at your bytecode earlier and it had like R was your working result. You had like add R1, which would mean if you did like a sub 2, 1, then this would set R to 1. So then R would be the result of whatever you did last. This R is your working result. So you can you can use your working result and say, okay, put it on the left-hand side. Oh, no, we're gonna put, you know what I mean? You can decide what to do with your result and where to generate it. Like that, or anything, really. And then you could have little working results, like WR, right? So your working result could be like, you sub 2 from 1, you mul 3 from 2. See, it would just mean that when you execute your bytecode, you have to remake a prat parser. It would suck. Eternal Wild Fox says, thanks for explaining the basics of the prat parser. Of course, I do my best. But yeah, I would not know how to generate bytecode from tokens directly. Incorrect operator precedence, like having the correct order. That would be very hard, because I can generate a tree in the proper way, and then work on the tree and go, okay, whatever is at the top happens last. Eternal Wild Fox says, I'm going to think about it. Very cool, very cool. But yeah, it's probably doable. I'm just not willing or smart enough to solve a new problem, apparently. Okay, so where were we? We helped out Eternal Wild Fox, I hope. Or just confused him more. Either way, life goes on. Hopefully everybody is doing well. We had an amazing pull request with a Rickroll. And now we're going to fix the messy get working tree. And I'm sure you guys don't care, but for a while I had like a bunch of old code. All these files were just here. which is horrifying. It was very messy. So now let's try and add a git ignore to ignore some of the common and suggested files that should be ignored by git. So let's just write a git ignore. So I think anything called build we should get rid of. I think anything called win, lin, let's go with, what else? Debug, release, test, test. What else do we need? We could do like the full words. We could do debug, release. So these are for Cmake build trees, at least the common names. I think I should just do win star like this. I think that's the way to go. Will that work? What do we have in the working tree now? We have .cache, so we have Ccache. We have Ccache build artifacts. Sure. And then this will be Cmake. We'll track the git ignore. Okay. We have lnx is apparently what I used for Linux. Okie doke. Anything that starts with a hash. Backup files. How do I write a hash in here? Do I have to do a backslash? How does this work? That didn't work. So, hey, I tried to recompile. God damn it. Oh, it's gonna happen so much now. That's pretty awesome. I meant to hit G or Control XG, but I did not. See, that still doesn't catch these. So do I have to do like that? I'm wondering, while peak is less than or equal to 2, number, binary number, where 2 is the precedence. Okay, so you're saying, how would, what's the other handling? Multiply is 2 in precedence. So while peak is less than the current precedence, number, binary number. So I'm assuming those both parse and generate is what you're doing? Number, binary number? How does the binary get the right-hand side? Adderson28 says, hi, Lens. Hi, chat. How are you doing? Hello, Adderson28. How's it going? We just got rickrolled by our own compiler. So I can't ignore these for some reason. What are they? I don't think we need this. Okay. Examples. I feel like the examples folder should be included. We have the greatest common denominator calculated by Euclid with no division whatsoever, because we don't do division yet. And we have our git ignore. We should probably save the example for a different commit. It's a little confusing. Compile commands.json, that's definitely a build artifact of what? This is going to be language server. So compile commands.json, anywhere you might find them. Eternal Wild Fox says, yeah, I am still a bit thinking about the algorithm, but you are on the right track. I think you are incredibly on the right track, Eternal Wild Fox. Because it seems like if you eat tokens while your precedence is lower, then you could like continue to build them on top, like build your result in the bytecode, and then you could use that result in the next time that your precedence changes to higher. Yeah, I think I believe you're getting there. You're definitely getting there. It's starting to look good. Okay, so let's make this get ignore a thing. We are going to get the commit. How about that? How about that? And we're basically going to say add basic dot get ignore. I think we don't have to get more complicated than that. Let's do examples. So we have GCD Euclid. We could also write like a factorial. I mean, I guess we'll just keep that in, let's just rename that file, actually. I don't like interesting math. I feel like there should be more interesting math. I'm gonna rename this file to, we'll just call it greatest common denominator. Denominator. I think that's right. Ooh, something's not happy that I renamed that file. Hello? Oh, I'm an idiot. I get it now. It's asking me which file I would like to rename, and I'm like, you know, this file that doesn't exist. Could I? Yes. Sure. Yes. Where? So this file exists. It's not in the get ignore, but it's not here, which I find very interesting. Okay, we're gonna have to do like a custom git add, I guess. Examples? No? Hello? Git add examples slash, what is it? Greatest common denominator. They're ignored. What? Oh, why is it ignored? How ignored? Greatest common denominator. Oh, it has test in it. I get it now. So TST never happens, but TEST definitely does. So we're gonna have to have test at the beginning or test at the end. Even test at the end might cause some issues, but we'll do that. Maybe I should use a stack and pop them off which I parsed. That would most definitely work. Where as you're going, if precedence happens, you either push to the stack or pop from the stack, or just generate your bytecode. So if I have the token 1 plus 1 times 3, the first run gets 1 times 3, pop them out, parse the remainder plus 1. Yeah. Yeah. Basically, you have to say while precedence of the next one is greater or equal, keep going. And then when you finally get to the highest one, generate that bytecode. And then you have to go backwards, like I was talking about in the pseudocode. You have to like go forwards while your precedence is greater than or equals. Then you get backwards and you go, okay, I've been here, parse the right-hand side into the right-hand side, because you can always do that. But then the left-hand side is going to become either this result popped off the stack or the thing you just parsed. And your precedence will tell you which one of those to do. And then you're going to have to go backwards through all of the operators that you went through. You know, you're basically going to go forwards, backwards, forwards, backwards, forwards, backwards type of thing. Like, go to the highest precedence. Go back to where you started. Go to the highest precedence. And then it's going to be kind of one of those. But you are correct. That's a great algorithm. That's really awesome you just came up with that. Okay, so we have greatest common denominator. Hopefully it's not ignored anymore. It still is ignored for some reason. Greatest. I mean, it seems like... here it is. It's in examples. It's now untracked. There we go. We should also make sure that this works. So we're going to remove our dash dash aluminium flag. And we're going to try our greatest common denominator. Function, yeah. Invalid syntax, function parameter definition must be a variable declaration expression. And what's the problem? So we have this function, and it's saying its parameter definition is incorrect. We have a variable declaration as the parameter, but then we're saying invalid syntax. So the parser is spitting out invalid syntax. RPWH says, yeehaw! How's it going, RPWH? It's so good to see you. Thank you for tuning in. Okay, so we did, so we're going to the parser, and we're looking for function, parameter, definition, blah, blah, blah. So if working result type, see, I think this is wrong. This should be stack result. I'm fairly certain. Because the parameter, what's the stack result? The stack result should be updated to, the thing. So maybe that's what our issue is our working result is different from our stack result. That's a lot of dereferencing. Like, just looking at this scares me. This is incredible. Still invalid syntax. Well, what is it? Could you tell me what it is instead? Did it not do it? It looked like it didn't print. Maybe it printed up here. It's printing none. Is that true now? Yeah, it's printing none. Why are we printing none? How is stack result none? That doesn't really track. We can't parse something and get none. So stack result is incorrect, maybe? So maybe stack result for the first expression isn't set, and that's causing some issues. So let's look at defun params as our stack. Stack result is definitely set to the first parameter, and then we continue. We parse into first parameter. RPWH says, I'm good, thanks. Where are my spoon picks? I literally haven't been outside. I'm so sorry. I do have to show you the tiny flat spoon. I also could make a node object or struct with a parsed equals false to help with the tracking which tokens are parsed. Yeah. Truthfully, you just need a pointer to where you started. Right? Like, you just need to save, okay, I'm on the 0th token. If these are all numbered and they're in an array, or you just have to save a stack backwards, like a look-back stack. So if you're parsing 3 at the moment, then your look-back stack would contain multiply, then it would contain 2. There's a lot of ways to do it. But yeah, parsed equals false, that would also work. So you could just go backwards until, okay, parsed is false, start going forwards once more. Totally would work. There's no reason it wouldn't. So we have none. How is first parameter none? That's a little confusing, is it not? And maybe it isn't none. So let's go up to print node and think about what could happen here. Function parameter definition. So stack result being none. What else could we check? Like, where are we in parsing? Okay, maybe, okay. Do we eat the comma? Is that, like, did we just make a silly mistake? I don't see us eating a comma here. Chat, please make fun of me. We didn't eat the comma. Oh, Christ. Okay, so basically, there's a comma. Like when we are looking at our code, let's look at an example. We're gonna copy a file from old code. We want the pointer example. I want that. Pointers. Sure. So now I want to open examples pointers. Okay. Hey, it even, oh no, it didn't. That's assembler. I was like, it opened in the proper mode for some reason, but it did not. It opened in the very wrong mode. That's better. That is better. But yeah, RPWH, I will get you your pictures of your tiny spoon right after this stream, because I'm gonna be heading out there again. And then I'll get you your pictures, I promise. It'll happen. But yeah, it's I'm a very bad blacksmith, I've figured out. But I'm going to get better. It's what learning is all about. Okay. So with our little pointer example, what was I what? Oh yeah. I don't know why I looked at the pointer example when I could have just used the example that we're parsing. Don't ask me why I do things. So we have a, which is an integer, and then a comma, and then b, which is an integer. So what we're going to do is say, hey, we need to eat that comma. So I think we can expect things like this. Woo! I think that's fine. And then we just have to say if expected.done, we basically have to say error syntax. And the syntax error comes from the fact that expected another variable declaration, another parameter definition, but got end of file. I think that's good enough. Negvorsa says, hi everyone. How's it going, Negvorsa? It's so good to see you. I am so happy you have tuned in today to this epic compiler work. We are working on parsing of multiple parameters and functions because that is something we apparently broke at some point. Return type of last expression in function does not match function return type. Why do we have this? What? Shouldn't we only have one with A and B? We've definitely got some issue going on. Oh, it's for the if and else. So the function has children environments in the if A section. So this is if A. This is else A. This is if AB. And this is else. Okay. So these are if scopes. We really should have like debugging, better debugging of environments because it's kind of rough at the moment. But we'll get there as we go. We'll get there as we go. Well, we are now parsing, it seems, properly. But we're getting a mismatched type error. Return type of last expression in function does not match function return type, which is confusing. A is an integer, and it returns an integer. This returns an integer, so obviously it'll be fine. I think the issue is that we're not setting the return type of an if at all. So we're saying, oh, the return type of this if is the last expression, because we're having ifs as expressions. So effectively, the return type of this if, we're not going to know it. It could be multiple things. So maybe we don't deal with that at the moment. RPWH says hi. And I think I'm going to go with an optional comma so that it's not enforced. Like if you just wanted to do this, that's fine. I don't really have a problem with that. But the comma can be there to separate them. And currently we have our type checker doing multiple complinations on the function. So basically we type check the expression, which is an if, and we go, yep, that's not a thing that we do. So our return type is just whatever we pass in, which can't be that good. Cannot be that good. So let's try and handle that, right? So it would be, I guess, case node type if. And here's the thing. An if may return either its then or its otherwise type. So we just have to say, when we're type checking an if, get return type of then body and otherwise body. Because they may be different types. And I don't know what we should do when they're different types, or how we should handle that, or if we should only handle that when it's within a variable reassignment so that we have to worry about the return type, or I don't know. I don't know. Either way, we'll think about this. So return type of then body. Hey! Thank you so much. We have had a donation come in. The message is, to master the way of the sword, one must first conquer the spoon. And that is from RPWH. Thank you so much, RPWH. We love you so much. Thank you for that $10.80. That is amazing. I very much appreciate the donation. And welcome to the club. If you would like, I can run outside right now and send you that picture of the spoon. I will do it. I'll put the stream on pause, and I'll go do that. Because RPWH, I appreciate you. I very much appreciate you. RPWH says, it's okay, Lamau. I'll do it. I'll run right now. Oh, this is gonna be a mess. Oh. Thank you, RPWH. I really appreciate you. I appreciate everyone who watches. But that donation really makes me feel grateful. Thank you so much. We will continue with this epic stream. But yeah, everyone give a pog champ to RPWH. He's a pog champ. I'm putting one in. Pog champ. Funding your tutelage of the sword. Yes. You honestly just bought me like an entire bag of charcoal. So I very much appreciate it. You very much funded that. It's happening. So get return type of then body and otherwise body. If it exists. That's the problem. So what's the return type of an empty body is something we have to think about. It's probably just none, right? And also, how would a function that returns none work? Would it just, like, nothing is returned no matter what? Or just the last expression is returned, even though it could be of any type? I don't know. I don't know. Alrighty. So with our little funky language here, we want to figure out the return type of the then body. So let's print out this node. So I'm just curious what it looks like. So we have it's fairly complicated. So we have a condition, a then, and then an otherwise. Okay, it's not too complicated. So effectively, what we'd like to say is get the return type of the last expression in the then body. So we're going to need a node pointer. We're going to have to like do our little silly protection. We're going to have a node pointer, which is our last then expression, which is going to equal our expression, children, which gets us to our condition, next child, which gets us to our body, this none here, and then variable access, a. So we need to do children. While last then expression, next child, last then expression, equals the next child. We're going to do the same thing for the last otherwise expression. And we're only going to do this if this is non-null. Okay, so we have our last then expression and our last otherwise expression. So with our last then expression, we would like to say last then type is equal to type check expression on the last type of the if. Also, we should probably have something like this. So we're going to type check each expression as we go. And we're going to need context and context to enter. And result type. So this is going to be node pointer last then type. So we're going to say, yeah, just then type. And this will just be a node that we write into. And we can then free when we're done. Alrighty. Haha. So we type check all of our expressions. What's the issue? Well, that shouldn't be that anyway. There we go. So this will type check every expression from, yeah. Also, these are the wrong contexts, I know, but we'll get there. Alrighty. Eternal Wild Fox says, I believe mine algorithm can work if I extend the number function to also check if the left or right side already is parsed. If it is parsed, I need to use the result from the stack. Nice. Yeah. That will work. I'm pretty sure that will work. So probably gonna need that here. And basically, this will type check every expression in the then and every expression in the otherwise, and it will also set the return types to the proper thing. So then all we have to do is say, okay, our then type, we see we can return two things. So currently we're just going to say that we have a result and it's our then type. This is to-do/fix-me. This is very bad and very broken. But hey, who cares right now? All right. So we basically, this is very bad and broken. We need to set our return type to two possible types. One for if, one for else. Or we could enforce that if expressions with else bodies. Okay, or we could enforce that if expressions with else bodies must return same type. I kind of like that. So let's do that for now. Yeah. We'll just do that. It's not too insane, right? Enforce that if expressions with else bodies must return same type. So if you have like if A, you can't then do if and return a string, because then you would be doing kind of like dynamic typing, which I don't really want to deal with. Negvorsa says, why not check if both are equivalent? Yeah. Yeah. Negvorsa, you had the same realization as me at the same time. Negvorsa says, in Rust, last expression is a return only if not ended by a semicolon, ... True. But not in this. Everything's a return expression, baby. That's what we do. I don't know why, but it is what we do. Eternal Wild Fox says, wish me luck, because I'm going to write it into code. I'm excited. Oh, also I didn't, I don't know if you wanted this. I forgot to paste it into the Discord, so I'm going to go do that. Eternal Wild Fox, I'm sorry. I forgot to do this when I said I would. Well, this is like pseudocode, so it doesn't matter. Perfect. Hopefully that helps. Sorry, I forgot to paste the pseudocode. Hopefully that does anything. It doesn't just confuse you more. Okay, so we now have GCD Euclid. We can finally parse multiple parameters. And we're still having the issue of our return type of our expression not matching. Invalid argument, binary operator minus. Why is that an invalid argument? Expected argument, an integer. Well, that's what this returns. So I'm not sure what you're talking about there. And also, it's not causing an error. So that's a little confusing. In any case, return type does... Okay, so we still don't set our actual result type. So we need to set this to result type. Then we need to say if, basically if there is an otherwise, we need to enforce that if expressions else bodies must match. So the idea would be that otherwise type, so we want to type compare otherwise type and what? Result type. And we want to say if that equals 0, then there's an error. And that error pertains to a type error. And say if both branches, I'll say all branches of if expression must return same type. Sure. let's hope that that works. And see how it goes. We also don't need this outside of here ever, so we can do a little bit of a less allocatey milady. All branches of if expression must return same type. So we're going to print the node of the result type. And we're going to say then type. Sure. Why not? And then we'll do otherwise type. Eternal Wild Fox says thanks anyway. Of course. Int 0, otherwise type is none. Well, that, what? Otherwise, it should be an if. Which should set its result type to its then, which is a function call. So I should basically say it's being none here. So I should say if otherwise expression. Then do all that stuff. Otherwise, leave it alone. Yeah, it still didn't work. So we have an expression. Could you print it out for me? I can't write here, but I can here. I should say error and print return error. I can do that. Argument does not match declared parameter type. Okay. Argument is a binary operator of minus, and the expected argument is an integer. So you think that would work, but we say argument type does not match. So in GCD Euclid, we have two integer parameters. A is an integer, B is an integer. So we have B minus A. These are both integers, but it says argument type does not match declared parameter type. So what is argument type? So we have invalid argument, bleh, expected argument, bleh, but what's our expected type? So, not our expected type, our invalid type. Argument return type. It's either in result or type. What do you think gets in? So type is the return type of the given parameter. Look at that. So type contains our parameter. So the argument return type is a symbol integer, and the expected argument is a symbol integer. So what is our issue? So what's our expected type? It is in what? Expected type is in result, it looks like. And we say build our whole tree. This is so stupid. We have to redo all of this so fast because this is not right. Not right. Okay, so the problem seems to be what? So we have symbol integer, symbol integer. So argument return type is a symbol, which we already know is probably not a good thing. And then we should say, I'm just going to comment this out for now. Expected return type. It's an integer. So we're just not resolving the symbol properly. Maybe for a binary operator return type. So what's our result set to? It equals value children next child. Yeah, that's definitely going to be our type symbol. So we should probably not return our type symbol. And probably should return it resolved, right? We still haven't decided if type check expression should work in symbols or not. But currently, integer does not work in symbols. Integer returns integer. But maybe it should return symbol integer, but then we'll have to compare symbols everywhere, type symbols, instead of comparing types like we currently are, and then it's a whole thing. So the quicker fix is probably just to resolve the symbol of a binary operator return value. So we really should have this simpler. Resolve symbol of binary operator return value. I think that makes any amount of sense. Alrighty. Also, RPWH with the Ferris pet, Lamau. Resolve symbol of binary operator return value. So effectively, we need to say result type needs to be written with this here. Bang. Hey, look. It worked. We fixed it. Does it actually work? Also, we should add to the getignore code.s. Very common, code.exe and code.o. We should really just have anything.o. And anything.exe. And anything.s. That's a better getignore, I feel like. Okay, getting rid of those. We're going to add pointers. Perfect. So we get some more consolidated examples. And as you can see, here we have our thing where we push 88, we push 32, then we call Euclid. In Euclid, to get the greatest common denominator, we say if a equals b. So a is moved into racks, b is moved into R10. We have our false and our true values in R11 and RBX. Then we have a comparison between racks and R10. So if they are equal, we can do this conditional move of RBX into R11. So RBX is 1, our true value. R11 is our return value, which is by default false or 0. So if they're equal, we'll move 1 into R11. We'll test R11 with itself, and if they are 0, the false value will jump past to our first otherwise label, L0. Otherwise, we'll stay and say variable access A, move it into racks, which technically we don't need to do. We already have that, but again, we're not quite there. We have move racks into R10 because why? Oh, R10 is the return value of the if expression. So racks, if we go down the if then A, this variable access, needs to be returned from the if, so that's moved into R10. Then we jump to L1, which would be past the first otherwise, down here. Move R10 into rack. So we just return the if expression from the function. So if we followed the then, we would jump to L1. No, we would jump to L0, the JZ. And in that case, it's the if otherwise, and we would have another if with a is less than b right away. So then we would say, okay, axis A, axis B, do the false and true values again. Compare, move, if less than, looks like the right one. Test RBX with itself to see if it's 0. Then we say, okay, if it's not 0 and A is less than B, then call GCD Euclid with A and the B minus A. This is looking like it'll work. So we call it with 88 and 32. I'm pretty sure 8 would be the greatest common denominator between these. So let's try and run it. There are multiple ways to run it. So let's try and use GCC to generate an executable, right? And hey, look, it worked. So now we can run code.exe. And you see, if we check our messages, shell command failed with code 8. That means that our return code was 8, which means that the return code of this function was 8 with 88 and 32. Perfect. So our greatest common denominator calculation worked out. Paug. Paug. And if we increase this or decrease this by 8, then we should get 16, because now they are both multiples of 16. So let's see if we now get 16 with a recompile. You can see the number's 80 now instead of 88. And then regenerate and rerun. We'll do it all in one step even. And check our messages. Shell command failed with code 16. Look at us. It does math. It does math, chat. We have a greatest common denominator. Haug. Okay, let's do it. So we're going to update our examples. We can put this back to 88. It doesn't matter. We have comments. We have code styling. More comments. And a bunch of type checking to fix things. So we'll add to the git ignore, and we'll add to our code style, just to kind of include some random things in this commit. Negvorsa says cool. ... Oh no. Is it not cool? I thought it was cool. Greatest common denominator. We did it. It's our own language. It's being type checked with if expressions returning a value. It's happening. My internet took a dip there, but it's coming right back. Ooh, it's coming right back down. Hopefully we don't cut out. I love you guys. If I cut out, I love you all. Oh, we're back. We're back up to bitrate. It's sketching me out. My bitrate keeps going down to half of what it should be. I'm in the red. I'm in the red. So let's commit our changes and basically say update examples, create examples folder, and consolidate examples into it. That's pretty much all we did. Eternal Wild Fox says, so implemented a lexer to token index method. Nice. So you can just get a token at an index, which I need for mine algorithm. Nice. That's definitely a way to do it. Definitely a way to do it. And now let's put in all our little fixes. So this is going to be fixing yes. This is going to be fixing token at index, I mean. Nice, so you have all your tokens in an array or something, and now you can access them by index. That's awesome. Are global variable and static local variable technically treated the same way? technically treated the same way? Yeah, they will be. They'll both just be like allocated in the data section of the executable, or read-only data if it's immutable, right? But global variables will also be in the data section, or the read-only data section. So yeah, I'd say they're treated the same way technically. They'll both end up as symbols in the object file. So this is going to be parser fix broken handling of what? Fix broken handling of function parameters. We forgot to deal with the comma. Lol. For the type checker, we now type check if statements, and binary operators return their thingamajangle. We also updated this error message, which I'm fine with. So now we can say type checker, and we're gonna say if now type checked, as well as binary operator bug fixed. Binary operators did not resolve their return type symbol, and instead just returned the symbol, which is not how the current version of the type checker operates. It operates on raw type values, not their symbols. In the future, it would be more efficient, easier, and less squirrely, I'll say, to just compare type symbols for type checking. But who knows? Woohoo! Okay, then there's also if expressions now have both of their branches checked to ensure that they return the proper type and the same type, so that the if expression doesn't allow for dynamic typing, basically. Hopefully that makes any sort of sense, because that's what we just did. Alrighty. It looks like we did that, so I think in our to-do, we did that. It's done. Whoops. Have better build instructions for other tool chains. So in our README, currently we supply GNU bin utils, right? But what we would also like is some other options. Something like GCC. And I think you can also use Clang. Something like this, but you have to set target to like that. Let's test. Does this work? I'm literally just going to copy paste and press enter. Shell command succeeded with no output. It worked. So now I run code.exe, failed with code 16. Hey, do I still have 80? Oh, code.s I didn't recompile. We still have 80. So yeah, there's how to use LLVM/Clang. Is there anything else we really need to deal with? We have Clang, GCC, bin utils. What else? What else? Neg Vorsa says, can you elaborate more on your strategy to handle scope visibility? What is scope visibility? Like shadowing? I can. Let's check it out. So basically, if you create a global variable, you can name it anything you want, as long as it's not a redefinition of another global variable. When you have a local variable, it can't be a redefinition of any variable in the same scope or any variable in a parent scope. So, or not, it can't be a redefinition of any in the current scope, but it can be a redefinition of variables in another scope, and this will shadow the actual definition of this A. So when you access A in here, you'll access this one, the closest scope, and not this one. So that's kind of scope visibility. As for like if and else, I think, if and else also create their own scopes. So if we have like something created here, like an integer, we can't use it in the else because it doesn't exist in this scope. These are both like sibling scopes, so they don't have access to each other's things, but they both have access to the parent. Is that making any sense? So scope visibility, if I understand you correctly, is like, can this scope see this variable? But basically it just goes for the closest definition. So like function parameters are the same as just doing this at the top, effectively, scope-wise. They're just here in this local scope. Does that answer your question? Hopefully. Or do you have further questions that I can answer to clarify? Because I will do my best. I will do my best. I know I'm not good at understanding both people or things, so I'm at a very, very great place to start, you know? Usage. Run the executable from a shell with a path to some source code as the only argument. That's definitely not how we use it anymore. Currently, we print out the furthest progress we're able to make. Eventually, we'll output compiled source code. We do that now. So, running the executable with no arguments, running the compiler executable with no arguments will display a usage message that contains not all, I guess, because -- aluminium isn't in there. That contains compiler flags and options, as well as command layout. Negvorsa says, are they attached to context? Yeah. So basically, a context contains all sorts of things. A context is a scope, is how you can think about it. The way that we have context in our code, and in our code base, a context is a scope. It contains functions, it contains variables, it contains everything like that. So we basically have the parsing context is basically the scope, right? So when we parse a variable declaration, for example, somewhere, variable declaration should be, oh, I need to do variable underscore. That's what my problem is. But you can see that we set it in the environment of the context variables, and we say this symbol for this, for example, symbol for n would be equal to like a for this integer here. And then it's mapped to its type symbol. And its type symbol is this here. So we map a to integer. Hopefully that makes sense. But yeah, they are attached to the context. Variables are, functions are, binary operators are, lots of things. Lots of things are in scope. Alrighty, so we have greatest common denominator. We could do factorial. I think we're just going to call it fact. We'll take in n. We're going to turn on unmode. We're going to return an integer. And let's think about a factorial. in the simplest case, we would just say if n is less than 2. So if n is 0, 1, or less, right? What should we return? We should just return 1, I'm pretty sure. Because 1 factorial is 1, I think. 0 factorial, I don't even want to think about that. Would it be 0? I guess it'd be 0, because anything multiplied by... But 0, you don't... Okay, I'm not going to think about 0 factorial. We're just going to return 1 and not think about that. Lamau. But if it's not that, then we should return n times the factorial. We could also say if n is less than 3, return 2, but... 0 factorial is 1? 3 people knew that off the top of their heads, apparently. What's the concept? Also, why did my mic get turned up? Am I louder? Am I too loud? If I'm too loud, let me know. I'm going to turn myself down. So, what's the concept of n factorial being, or 0 factorial being 1? 2 times 1 equals 2, right? So 2 factorial. We have 3 factorial equals 3 times 2 times 1 equals 6. And then we have 1 factorial, which is just 1, which it goes, oh, okay, this makes sense, which equals 1. Next of x says, no, not too loud at all. Okay, I'll turn myself up a bit. Hopefully I'll where I was. We'll see how it goes. So 0 factorial is also 1? How does this make sense? Rohanna says, is he even speaking? Lol. Lol, lol, lol. So 3 factorial is 6, 2 factorial is 2, 1 factorial is 1, and 0 factorial is also 1? To me, it would seem like if it's 0, that would make sense. Because that continues the pattern. Like, oh, 2 times 1, 2 times 1, nothing times 1, and then just nothing. Next of x says, how long have you been working on this compiler? Like over 72 hours of work. Waffle says, oh, that's a great explanation. Awesome. Hopefully it helped somebody. It helped somebody. Also, you're on stream, Waffle. Hello. It says thing.exe ASCII text. Oof. Yeah, that's a problem. Nexovec, that's a major problem. That's not on my end. That's your compiler. Nexovec says that's not even that much. I mean, 72 hours of work into a single project is a lot. Like, I would charge someone $1,000 to do 72 hours of work. Because imagine a work week is 40 hours, so I've put in 2 full work weeks of a full-time job into this compiler. I've just split binaural parsing into different functions. What? Oh, so you like say, if you find a plus, do a custom thing. That's definitely doable. If you don't want to handle like a million operators, like comparison and everything. Lol. So this should be a working factorial. I still don't get why 0 factorial is 1. I'll believe you guys, but I still don't know why. Nexovec says, I've put like 3 months of work into Cosmo Clash. I don't think that's true. You'd have to be working on it for like years. Have you worked on it for years? Because 3 months of work, I'm saying like not 72 hours of like, oh yeah, I started 3 days ago. I started 3 weeks ago, but I've put 72 hours, like probably 80 at this point, into the compiler. Because I keep track with all the YouTube videos. Factorial is the number of combinations possible with numbers less than or equal to that number. I see, so it has to do with permutations? I didn't know factorial had to deal with permutations. I guess it makes sense. I thought factorials could be used to calculate permutations, but you're saying permutations are used to calculate factorials. That makes sense. I had a backwards dependency in my head. I've worked on it for like 6 months. But that does, if you work on it 12 hours a day, then sure, you would have 3 months of work into it, right? But I don't think you work on it 12 hours a day every day. You may. You may. I'm not saying you don't. I'm just saying I don't think you do. Adderson says, in other words, math is awesome and scary. Lamau, it's true. So we can actually say, I want to add doc strings into this language, but I don't know how. Nexavec says, it depends on how it's defined. True. How many ways can we order a set with no elements? Here we need to stretch our thinking a little bit. Even though there is nothing to put in an order, there's one way to do this. Thus we have 0 factorial equals 1. Yeah, I do get that. I get that permutations, like, if you have 0 things, you can put them in one orientation. It's a blob of nothing right here. You know what I mean? Like, I get it. But if you have one thing, you also just have one thing or nothing. You can only put them in one thing. But if you have 2 things, then you have like a 1 and a 1, and it's like, oh, well, I can put them in this order, or I can put this one in front. And that's 2 ways to put them. But if you have 3, then it gets very complicated, where you have like 1, 2, 3, and you can do 1, 2, 3, 2, 3, 1, right? And this is where the number 6 comes from. So I see. Permutations, which are the different orders of the same set, is how factorial is calculated. That's very cool. I didn't realize factorial was defined like that. If n plus 1 factorial equals n factorial times n plus 1, then n minus 1 factorial equals n factorial over n, so 0 factorial equals 1 factorial over 1, which equals 1. Factorial for me, not permutation, it's me like order. Negvorsa says, factorial for me, not permutation, it's me like order. More like order, I'm assuming is what you meant. So, isn't permutations, so permutations is how many ways you can arrange a set, is it not? I may be wrong. A permutation is an arrangement of a set. Nexavec says, to me, it's just an operation. See, that's I'm with Nexavec, where I thought it was just like a number thing, where, oh, until you get to 1, just keep multiplying. But if it's defined in ways of like how many ways can we order a set, then that's definitely, with n elements, then that's definitely correct, with 0 factorial being 1. Permutations are how I would apply it, Nexavec says. So we probably have the 2 mindsets that come at factorial, the 2 common understandings. We have like permutations, and then we have our understanding, me and Nexavec, which is like, it's just numbers. We never got taught it in a way that was like, it works on a set of numbers and figures out how many ways you can arrange them. We were just taught like, factorial is 3 times 2 times 1, and that's it. Which is pretty common, at least where I am. Very cool. In any case, factorial of like 6, factorial of 5 is 120, right? Or, because 4 times 6, we know 3 factorial is 6. 4 times 6 would be 24. So 4 factorial is 24. So 5 times 4 factorial would be, yeah, 24 times 5, which is 120. So let's hope that we compile this program. Excuse me? Oh, I'm in the wrong spot. I get it now. So compile factorial into code.s and hope that when we use GCC and run this bad boy, what'd we get? I didn't see. Failed with code 120. Hey, chat. We have a factorial implementation that's very inefficient and will stack overflow for large numbers. So we could define better fact, right? And this has an accumulator. And in this way, we can not have to do so many recursive calls and take advantage of tail call recursion, which I don't think we'll do in our compiler yet, but we can take advantage of it, so why not? It starts off the same, but we then call better fact on n-1 and n times accumulator. Nexavec says, it depends on the exact definition, but it seems wasteful to have to define a permutation so that you can define factorial. Factorial is permutations, says nothing about either. True. With factorial, the largest number you care about is like 17. Yeah. 18 factorial. Just calculate that for me and get right back to me. It takes so long. Ookie ookie. So I believe this will give us the same answer. Hopefully. Invalid syntax. Expected type annotation following parameter list for return type of function. Oh, look at us. It says, hey, expected type annotation following parameter list for return type of function. That's literally what I missed. There it is. We did it perfectly. Our error message helped us out. Not enough arguments passed to function. Also true. Generated code at output file path code.s. Did you see that compiler assisted workflow? That was beautiful. 18 factorial overflows 32 bits. I think it was 18 at least, and it's like 27 for 64-bit. I think you're right. So with better fact, failed with code 1 and no output. This didn't work. Why did it not work? Because we return 1 eventually if n is less than 2. So this will return 1. But we didn't accumulate as we went. So we should say n times n-1, should we not? Shouldn't we do something like that? Which means we would need to do... we can't do that. Okay, so we can't do tail call recursion yet. Or we can, and I'm just not thinking about it in the proper way. Either way, we have factorial. It's another example. So we can add that in. And I say, why not? We'll do examples. Factorial. I think factorial is also one that's in the README, so it's good to have a concrete example. That's also in the README. So this, we would also like to update the README. Everything except for this, basically. Perfect. Nexavec says, I have done no work today. I know how you feel. It's okay. You don't have to do work every day. You just have to get through to tomorrow. You know what I mean? But I agree. I know that feeling, like, I gotta do something. I mean, I literally get that feeling so much that I go outside and hit metal with a hammer. For no reason. So, you know, that's how it goes. So this will be, we're just going to say readme, add more build examples. Or add build examples for more tool chains. Sure. We should also look into outputting NASM syntax and writing another backend. Alrighty. Looking pretty good. We have some more examples of how to build things. The language reference is still looking pretty bare bones, but you know, it does work. It does work. What else did I have in the to-do? We now have better instructions for Clang and GCC. Yeah. We could go in and break everything. I don't see an issue. Sorry, I'm just yawning. Gonna drink some water. So, what this this next to-do message says, it's kind of a big thing. It's gonna be kind of difficult, but I don't think we can't do it. Our current pointer types look like this. Pointer, pointer to integer. This gets converted into a syntax, into a node, I guess is what I would say. So I'm not in Markdown, that's the wrong thing. There we go, this gets converted into a node. That looks like this. What should I do? I think I'm gonna do example. Emacs? Oh, okay. Thank you. Took a bit. In this example, we're basically going to have a pointer with a symbol integer. Nexovex says, and my family wants me to go to a barbecue party, and I will go because I'm irredeemably irresponsible. That's awesome. I hope we manage to fix my compiler later. Bye. Bye, Nexovec. Thank you for coming out. I had a lot of fun. Definitely have fun at your family barbecue. Be nice to your family. Or don't if they're not nice to you. Stand up for yourself. Wherever you're at in your life. Oh God. Something like that. This is inefficient memory-wise and overcomplicates the issue. There is literally no need to have the pointer type be a separate node type or even a separate node. Negvorsa asks, does GCC optimize the generated assembly? Yes, it does. At least I'm fairly certain it does. I think it may, you may have to feed it a lowercase s. Because currently we generate code.S, and I think this may mean like literal assembly that we don't want you to touch. Because when you, I don't know, we'd have to see. Because like, -s says compile only, do not assemble or link. But, that's not what I need. I need there's basically two different assembly, I'm saying a lot, I'm so sorry. There's two different assembly options, and effectively GCC uses as under the hood. And I think there's like a big S and a small s difference. I don't know what it is. But yeah, I just use the big S, but I'm pretty sure it does. Because it's GCC. It's just doing a regular compilation. That's something we could test though. Pass like O2 to GCC and then do a disassembly. Negvorsa says -s for small size, O3 for speed. Well, let's try what we had then. So let's do code unopt. And then let's do code optimized, right? And then we can do dured. So we have code unopt and code exe. So effectively these should be different. So if we disassemble Is that what we have to do? So we object dump and dash D. What do we got? We got a lot of stuff. From NGW mainly. Just a bunch of nothingness. Wow. Oh, wow. Scheduler? Interesting. P-thread? This is a statically linked P-thread? Why do we have P-threads? So funny. Windows, you end up linking with everything. Because MinGW isn't, doesn't worry about stuff like that. There's a lot of disassembly here. Can you get main? So let's take a look. Rohan says, time for me to go as well. Guild Wars 2 Guild Raid is calling. Catching your progress later if you're still online then, or in the VOD/YouTube. Awesome! I'm probably not going to be online, so definitely check out that YouTube. Thank you so much for tuning in, Rohan. Rohan. We had a great time having you, and I really appreciate you watching. So I'd go with no, it does not optimize the assembly. Based on this disassembly, but this is the unopt, is it not? Yeah, so now let's look at code.exe itself. And look for main. Main. There we are. Yeah, no, it does not. There's no, these are the literal instructions we gave it. So they stay. It does fill in the memory addresses, of course. But it just keeps our assembly how we said. At least that's how it appears, Negvorsa. Hopefully that answers your questions. Okay. What we should have instead is a pointer and direction counter. This can be a part of every node, and when non-zero, indicates the amount of pointers to the type of the node itself. I don't think I said that great, but basically, we'll have our example. It'll be a symbol integer with a pointer in direction level of 2. Hopefully that makes sense. So instead of having like pointer to symbol integer, we're going to store it as symbol integer with an indirection level of 2. And hopefully this allows for much less tree traversal in our code and more direct data comparisons. Because we can just compare in direction level and then compare type symbol, and we never have to worry about fucking this thing, right? And a type will always be one node, which is another advantage. So yeah, I'm thinking this is the way for us to go. But it's going to break everything because currently we use this system. So hopefully you're ready to break everything. Let's think about it. We don't want pointers as a type anymore. And we would just like a integer, an unsigned integer, really. And this would be pointer in direction. And when we create a new node in node allocates, it should be set to 0 because we use calloc. Negvorsa says that was informative, ... Which harder, generating C code versus assembly versus IRR? Intermediate representation. Okay, I was like, wait, what? Nothing is harder. They're all just different problems. I'd say it's harder to generate C code versus assembly. But it's also easier in some cases. You know what I mean? So like with assembly, you have to worry about register allocation. Like if we look at our code gen, you can see a lot of this is just register allocation. That's literally most of what this is. Code gen is easy. For assembly, it's register allocation. In C, it would be keeping track of scopes and stuff like that, right? Which would just be codegen context, this thing here. So I'd say with C, you have to worry about like how to fit your own language ideas into something that already exists that may not be possible. Like if you want to have functions as first class objects, it wouldn't be clear how to do that in C, right? It'd be like, oh, how do I pass a function around in C? Because there's no function type. So you'd have to make like a struct function with a function pointer. Like it'd be hard, right? Whereas when you have assembly, the problems you have to solve are like which registers to use. It's not really fundamental issues like how do I implement this thing. With intermediate representation, I'd say that's the hardest because you have to create your own entire semantics. Like, does it work like load into A, right? Do you have like load A and then you say 24, load B 32, and then add, and add just always works on A and B? Or do you have like add with 24 and 32? Also, can you add A, like the register A to 24? How do you do it, right? And then where does this add into? Where does this result go? So intermediate representation has a bunch of like, just a bunch of corner cases that you have to handle. Whereas assembly is kind of like, it's already, everything is rigidly defined and there's not much you can change because it's how the hardware works. Hopefully that made sense. So on second thought, I would say assembly is the easiest, C is next, and intermediate representation would be after that. Because intermediate representation would just be crazy. It's just a lot to deal with. Then you have to figure out, okay, how do I convert this intermediate representation into C code or into assembly or into some other thing that can actually work, or create a virtual machine that runs it, or all of it is so complicated, right? But I'd say the easiest is assembly, assuming you know assembly. If you don't know assembly, C code might be easier to generate. But assembly's not complicated. You can learn it in a week or two and go, okay, that's it. As long as you don't like dive deep into macros or sections or optimizing things, it's like, yeah, just learn the basics. What's the stack? How do you make function calls? How do you create a variable? Stuff like that. So with a node, we no longer have pointer. So we're going to have a bunch of issues. And hopefully it points us everywhere that we were having issues. Also, we should probably... Was there anything that we had unstaged? Nope. We committed everything. So I'm just going to push my unmerged changes in my local branch. Bouche bouche. Those are now done. Negvorsa says thanks. Of course, anytime. I love answering questions. And it makes me think too. Like, ooh, I don't know which one would be harder. I just picked one. I didn't think about it. So we have a pointer in direction, which will be 0 by default. So now we can go here. And so we have node type pointer. So in a variable declaration, if it's a pointer, it's always 8. So this would change from if node type is a pointer, because temp node contains our type, apparently, then if temp node is pointer, right? Which would mean that its pointer in direction does not equal 0. So if its pointer in direction does not equal 0, that means we have a non-zero in direction level, which means it's a pointer. Pointers are 8 bytes, always. At least for now. And else, if pointer in direction level is 0, we should get the type size from the type's environment and just use it. Get the size in bytes from there. Perfect. Perfect. We have subtract type size in bytes from stack pointer. Yep. Looking good to me. Keep track of the offset and keep it in CodeGen context in the locals environment. That looks good to me. We may have to deal with CodeGen of if in a slightly different way. So a variable reassignment. That's not what we're dealing with. We're dealing with type pointer. So result type equals node type pointer, address of, so this is type checker. So address of, we should just say result type is equal to, well, here's the thing. We also ignore an error here. That would be confusing. So a result type will no longer be a node type pointer. It will be whatever this is. The variable access return type. So then, all we have to do is say result type. See how much easier this is? Pointer and direction plus equals 1. Wow. That's much easier rather than our whole crazy thing before. We basically just say address of a variable access, type check the variable access to get its type mainly, and with the type say, yeah, it's a pointer, one more level of pointer to that. Man, that's nice. What else do we got? It's in the same spot right here. Okay, so in a dereference, we should say the child return type needs at least one level of pointer in direction. So if it's equal to 0, then we have to say dereference may only operate on pointers. Now, where else? We have while expected type symbol children and expected type symbol type does not equal node type symbol, result type equals node type pointer, blah, blah, blah. So this is rebuilding. This is a perfect example. So we get the return type of the given parameter, which could be anything. And then we get the expected type, which is here. And we say type result iterator equals result. So we basically copy as we go from expected type symbol into result. So all we're going to do is basically do node copy this into result. We don't have to do this because this node copy will include the amount of pointer in direction. So we don't have to do like this whole thing at all. And then we can basically say resolve the type of the expected type symbol, which will get us the actual literal type. So then we can compare type and result and make sure that they match. Is that making sense? I think this is all making sense. Now we have case node type pointer. Yep, we're never going to need to compare that because that doesn't exist. Node type pointer, once again, does not exist. And parse type. Perfect. When we actually create a pointer, all we have to do is say the type doesn't need a new child, doesn't need to do allocation. Type pointer in direction plus equals 1. Advance the lexer. That's it. So we should say expected a valid type following pointer type declaration symbol at. I think that's fine. We're saying we found an at, but there wasn't a valid type after it, so get going, fix it. So now we have type symbol, which is our current token, what we've lexed. And then we just have to say our type is equal to our type symbol. What does this really mean? Like, what am I trying to say here? So we create type symbol. So then why do I want type symbol? Well, here's the thing. Why don't I do this first? Right? I say type is equal to type symbol. And then free type symbol, I would hope. Because type symbol is just a node. The actual symbol it points to has been copied to type. So we free like this hollow shell of type symbol. So we create, see, we don't have the correct thing here. So this isn't going to work. Basically, we need to get all the pointers and keep track of the pointer and direction, and then set it. So we're going to do something like this. Indirection level plus equals 1. And then we can just say type pointer and direction equals indirection level. I think that's the way to go. And then validate that the type is a thing. I think that's also valid. Okay. Okay. It worked. I didn't expect that to work. I thought this was going to be very difficult, chat. Okay. Factorial works. Pointers shouldn't work, though, right? Oh, I'm in the wrong spot. Type is not found in environment. Type not found null. Okay, there we go. So type not found null. So it looks like if we look at pointers, where did we get to? We got to a variable reassignment to 69 in our first function. So we got here. And then we went, hey, type is not found in environment. So maybe at integer wasn't found? Let's think about this. So it says type not found null. That's all we say. So we're doing a parse get type and there's an error because of it. We exit with code 1. So that would be while parsing? No? So we use parse get type in parse type to ensure that the type symbol exists. So let's, I guess, print out C, and then we're freeing it. So this is a use after free, a UAF. I hope. Mismatched types. Dereference may only operate on pointers. So where'd we get to now? A little bit further, we got to function number 2, it looks like. Function number 2. Got through there, no problem. Function call, variable access number. So it seems like there shouldn't be any issue. We parsed all the way to variable access number, the very end. But apparently there's an issue, and it says mismatched types, dereference may only operate on pointers. So that's probably a type checker. And let's see what is happening. So let's print the node that we are type checking, just to make this a little easier on ourselves. So we have a dereference of the variable access putter. Right. And it's saying that putter is not returning the proper thing. Is that true? So putter should be defined here. See, it says putter is a symbol integer, which is fine because it should have an indirection level. Line 33, add another level of indirection. Pointers. Here. Or here. Probably not here. So line 33 of pointers. This should be okay, because numputter is a pointer to an integer. So the address of an integer variable should be fine. But if you were talking about somewhere else and not this line 33, let me know. So node type dereference. Basically, so when we dereference a variable access, we're getting integer. We're saying putter is integer. But I don't know if that's right. So let's think about what a variable access returns. Get type symbol from variables environment using variable symbol. So result type contains our type symbol. And then we say, yep, some more stuff that's broken. We copy result type into type. We set iterator to type. We say iterator equals the very last child. We then resolve the symbol. And when we resolve the symbol, we then update our result to that new thing. So our result type will be, yeah. So if this is a pointer to integer, I see what the issue is. So effectively, result type will contain our pointer and direction level. Right? Is that true? Because they're always integer. If I printf indirection as, what is it, an integer? You can see it changes. Sometimes we have pointers, sometimes we don't. And the problem is that after we update result type to type down here, it's always 0. So we're missing that information. So truthfully, I would like to say result type should keep its pointer and direction. But I don't think we even need to do all this unless we want to return the non-symbol. And I think we're moving towards a symbol-based type checker, right? Would the type checker ever need something that isn't symbols? I don't think so, because we don't need to know. We just need to make sure that we can get them in the context and stuff like that. So our result type should just be our result. We get int 08 and symbol integer. Okay, so now we just have to say for an integer, ooh, my stomach. Then result type, we basically should say, okay, we'll do this. This is going to be a node symbol. Can I do that? Probably not. So effectively, I'd like to create a symbol and say result type is equal to integer type. A label can only, okay. Gotta love C. Hey, I wish Rohan was still here. We got that code 5 for him. He loves these. So I should be able to free that without worrying about it. But result type is a symbol integer. Seems simple enough, right? So I'm not sure what the actual issue is. I'm sure it's elsewhere. So we were just in a reassignment and saying the right-hand side and left-hand side don't match. So where are we now? Can we get to a reassignment? We can. Can we get where they don't match? We do not. So right-hand side, integer 0. Right-hand side return type is the symbol integer. That looks pretty clear to me. We could look at the left-hand side return type as well. Left-hand side is the variable access A. Left-hand side return type is a symbol integer. Right-hand side is an integer. Right-hand side return type is an integer. Everything should go fine. So now type compare will say, yeah, if type doesn't equal type. Or, here's the thing, if A pointer in direction does not equal B pointer in direction. So they can't be the same type if they have different levels of pointer in direction. Wonderful. So they have to be the same pointer level, in direction level. They have to be the same type. And every child has to also compare properly. And we want them both to be null at the same time. So this makes sense. Should probably do something like this. That's a little more clear. Still exits with code 5, which makes sense. So do we even need to do the children thing? What if we didn't? What if we just returned 1 instead? So if they're not the same type, and if the pointer and direction level's not the same, they're the same. Well, that's not true. We also want to check that the symbol works, right? So let's leave this one intact. And let's write a new one. Type compare symbol or whatever. And we'll not do all that. And we'll just say str compare basically, or if str compare of our two things does not equal 0. So if we'll say A type does not equal no type symbol, or B type does not equal no type symbol, and string compare of A value symbol to B value symbol does not equal 0, otherwise return 1. So basically we're saying check that A and B are both symbols, A and B are both equal levels of pointer and direction, and that A and B have identical symbols. And if that's true, then they're equal, otherwise they're not. So I think this can be a char, it really doesn't matter. We're going to steal this into typechecker.h. and say if type symbols are equivalent, return 1, otherwise 0. Good enough to me. Okie doke. So now, when we type compare, and we've been going crazy on like making sure we have symbols, let's see what we got. Compilation still exited abnormally with code 5. So result type is our left-hand side, which refers to, I guess I have to exit to actually ever see the light of day. And it's a symbol integer. Pretty sure the right-hand side will be very similar. So now let's open up a debugger, our least favorite thing to do, and let's see what we got. See what we got. We're going to use Visual Studio just because we're on Windows and I'm lazy. Hopefully we're still dealing with pointers. Okay, and I should be able to run it, and we'll get our little, well, maybe we'll hit this breakpoint that's there from last time. Hey, abort has been called. Wonderful. Node type max equals 14. That's right. That should be a problem. So let's go to the parser, I guess. Node type max. Because node type max is now 13. Alrighty. Yep, and we reached that. So let's just continue and remove that breakpoint. Hey, look, exception thrown. Don't you love exceptions in C code? It makes so much sense. So, case node type dereference in typechecker.c. Dereference. So we type check the child expression, which should just be a variable access. I see. Look at this little ditty. So really, we just want to say result type pointer in direction -1. Okay. We're getting somewhere. We're getting somewhere. Mismatched types, return type of last expression in function does not match function return type. So now we're getting to type checking, and we're saying return type of last expression in function. So here's the thing. We can just use expression return type. That's already the return type of the last expression in the function. So when we copy our function return type into function return type and try and resolve its symbol, we don't actually have to do that. We can just say if type compares symbol on whatever this thing is, the function return type, then we don't have to do all that craziness. Wow. Argument type does not match declared parameter type. So we have an invalid argument numputter. Says expected return type is a resolved type, but the argument return type is a non-resolved type. So let's look at that. Okay, so we're saying that expected return type int 0, so result. Result is from the expected type symbol. So what if we just used that? Hey, look! Look at all the simplification we can do. we don't even need to do that anymore. Yeah, we're just gonna get rid of it. This is beautiful. We're cleaning up so much code. That just, it was so messy. And it actually works. Is our code insane? We don't have like insane numbers. Move 42, negative 48, 56. They're all 8. Multiples of 8. This is a good sign. Negative 40, 32. Okay, this may work. We're gonna try it. We made code.exe and run it. I'm gonna run this little ditty down here. Failed with code, I didn't see. Failed with code 69. I think that's perfect. That's what we expect. Because we dereference this pointer and write 69 to this pointer, which we pass numputter in, which is a pointer to number, which is 0 by default, then we return number. So it should be 0 if this function had 0 side effects. But its side effect is that it alters pointer. And pointer points to number, so number gets altered to 69. Beautiful. It works, chap. It works. And let's try and check foo as well. So foo, if we think about it, a and b are integers, so we have a pointer to an integer, which is the address of a. We dereference this pointer and write 69. A is now 69. Test pointer is a pointer to b, and we have a pointer, which is a pointer to pointer, which is a pointer to a. So this pointer to pointer, we dereference that to, and assign it to the pointer to b. So we say we have a pointer to the pointer to a, so let's dereference the pointer and make it a pointer to b. And then we update pointer to 42 and return a. So a should still be 69. But if it doesn't work, then it would be 42, or we'll get like type errors and crap, right? So now let's look at code.s. Should be simpler. Beautiful. And we'll use the same little things we have. And messages. Shell command failed with code 69. Hey, chat. It works. It works. We still need like block comments. We'll have to think about that. We will have to think about that. Woo! Well, this is fun. We just redid our entire type checking system in like 30-40 minutes. I thought this was gonna take so long. But I'm sure there's still some issues of like using parse get type and type compare when we don't need to. But hey, it's actually beginning to work. So get type and expected return type in temp node. And then we can just do type compare. So we can just use this directly like this, right? And we'll say expected return type of left-hand side is third child of binary operator definition. So value, our binary operator has 1, 2, 3. That's our third child. And down here we'll say right-hand side is fourth child. We'll steal this and use it here. And see how many errors that causes. None. Wonderful. We're probably not doing any math in this file. This would be my guess then. So let's do examples / greatest common denominator. And we get argument return type of integer value an expected return type of none. Well, that's a big issue. So GCD Euclid, invalid argument, binary operator minus b of a. So if we take a look at the example we're trying to compile, you can see that we're trying to call the function with b minus a, and it's saying b minus a returns a resolved thing, which I think we did today. Yeah, we did this today. I think we can get rid of this now. So nearly now. So if we look at greatest common denominator, it's saying mismatched types and the branches of an if are not returning the same thing. Obviously these are, so it's this if not returning the same thing as this. So this variable access returns the symbol integer, but this otherwise function call returns a resolved type. And it does return a resolved type. So we are just not going to resolve this type at all. And see what happens. Okay, that didn't work. So Negvorsa says, you were double checking error twice on line 240. Ooh, I am? Negvorsa, you're the best. Ooh, I am. Thank you, Negvorsa. I very much appreciate you. I don't know what I'd do without you. That's awesome. We're on line 300. So this is our function return type, but we don't ever actually use it, which I find interesting. So we set func return type to return type symbol. So when do we ever set like our actual result type? Oh, we copy right here. So result type is going to be equal to whatever this thing is. 229 also. Oof. Oh, it's true. It's true. Thank you, Negvorsa, Lamau. Grammar do Parser Boy says hello again. Hello, how's it going, Grammar? It is so good to have you. How are you doing? Thank you for tuning in. I very much appreciate it. So we can just do something like that. And then say break. That's better. So, hey, that's pretty good. So now if I tried to return, well, I don't know. If I tried to put in like the address of, this still breaks, right? Yeah, it says mismatched types. Expected return type of none. Oh boy. So address of probably doesn't set its thing properly. So it sets its result type to whatever its variable access is with a level of pointer and direction. That seems fine. I'm not sure why that would be none. Right? So argument return type is symbol integer. Expected return type is none. So is this what I'm seeing? Invalid argument? Argument return type? Expected return type? Yes. So what is result here? Result is nothing. We never use it, so it will be none. So what is our expected return type? It's this thing, is it not? Okay. It's the classic, right? Indirection will print out as well. So we'll print that out for, here, we'll do that for the type and this thing. So we have a wrong pointer in direction. So the pointer in direction, perfect. This is perfect. So we just need to be more clear on why it's happening, right? So address of variable access B, argument return type. So we have invalid argument to the function GCD Euclid. This is looking good. Grammar to Parser Boy says, yeah, I'm fine. I'm getting a little bit nervous, but it's okay. I wish I would know someone to help me fixing some bugs in the .NET backend. It's true. I wish I knew more about the .NET ecosphere. I could help you out, but I know nothing. You know, hear no evil, see no evil. That's me with C#. No, that's me with .NET. I'm okay with C#. I just haven't like built actual programs in it. I've made like scripts and games with it. Grammar 2 Parser Boy says, let's rewrite your compiler in C#. Lamau, let's rewrite C# using our compiler. Now that's that's where it's at, right? So we should say expected return type with indirection level. So let's have a little thing in the type checker. Print type node, right? Do we use print node? We'll use print type node. And we'll basically say we want to print out node text of type. So we'd like to printf a string. Looks like that. We would like to then print what? We'll print the indirection level. I guess we could say like for, what did I make it? I think an unsigned. For unsigned I equals 0, I is less than type indirection level. ++ I, and then we'll printf pointer to. That many times, right? Pointer to pointer to pointer to pointer to something. That doesn't sound too bad, does it? I don't think so. I'm going to take this whole thing, I'm going to delete this, and go to typechecker.c, and copy this. And then, whoops, go to typechecker.c, and figure out where I just was. Does anybody remember? I don't remember. It doesn't matter. I think I was in the expected return type area. Oh god. Yeah, here we go. Expected return type, print the type node, children next child. Instead of doing that. So let's see how that looks. Print type node is going to print out a new line. And let's see what that looks like. We get symbol integer still. That's all we got. We got symbol integer. So I feel like, what is node text? I think that's in parser. Yeah. So node text gets us a one-time use string in static memory. And it lets us know what type and the value of the thing. But I just want to print the thing when I'm type checking, so I don't really need to use node text. I just need to use type value symbol, right? Knowledge. Nearly. So then we're going to have indent, and we're going to say size t indent iterator equals indent, while indent iterator minus minus printf indent. This we could use like put char. What's the issue? Oh, typechecker.h needs indent. No? What? Oh, now I just don't pass. That's better. It's now expected return type that's indented to integer. Looks good to me. So now print type node. It seems like we are good. All I have to do is this and say, hey, argument return type is pointer to integer. Expected return type is integer. I think that's fine. We could also use like our indirection operator, and instead of writing pointer to, we could write at. Which one looks better, do you think? Argument return type at integer, expected return type integer. I feel like this is better. So let's do that. Then let's go to the one place it's used and say invalid argument blah. Argument return type is blah, right? Is something. So I want to be able to print type node like inline. So let's think about how we could make this work, where we can generate the text. We're going to have a similar thing where we have like type node text, pointer type. So this will be this thing, and we'll have like char buffer with set length. So we're going to have type node text buffer size, and just have it like 1024 or whatever. And we'll have our type node text buffer, which is an array of type node text buffer size. And effectively, we just need to use sn printf into our type node text buffer and our type node text buffer size. Oh, I gotta get out of here soon. I'm already running late. It's worth it though. This is a much better system. So type node text is going to return a char pointer. It's the same char pointer every time, but it doesn't matter to us. And we basically want to say offset. So we want to do the same thing, but we want to write just an at. And then we want to say type node buffer plus offset. Alrighty. So now, using type node text should replace this, and we should just be able to printf with a new line type node text of type. This adds a new line, which it shouldn't. And it works now. So now, all we have to do is call type node text instead of print type node. And say, argument return type is blah, but was expected to be blah. Hopefully this works. Bug line 22, size less. Bug line 22, size less. Ooh, you're right. You're right. So because we offset by offset, then that means we don't have access to our full buffer size. We actually have this size minus offset because we're writing that much into the beginning. Negvorsa, you are the best. You are the best. We still get that wonderful code 5. God damn it. Why? Didn't I just do this print type node? I see. So we don't have enough arguments. This is probably our issue. So this is going to be node type node text of type and type node text of whatever this thing is. That's better. Argument return type is add integer, but was expected to be add integer. I see, so we only return a singular thing. Yeah, I don't really want to do our label trick where we keep track of our offset statically. Well, why not? We'll have a static offset and then say if offset is greater than or equal to the type node text buffer size, offset equals 0. So the next time you call it, it'll start again at the beginning. So we basically have this array, and by keeping track of the offset in this way, we can ensure that we never overrun the buffer, but we also never have to deal with calling this multiple times and it not working. Well, it still didn't work because we need to return the proper string. So now you can see argument return type is blit, but was expected to be add integer. So this is interesting. We want to return the offset at the beginning. So this is going to be out string. And we're going to save it and say out string is equal to that. We did it now. We did it. It's a little complicated, but it's fine. So all we have to do now is remove our others and kind of make this a little neater. Argument return type is blah, but was expected to be blah. So now it spits out the error and you can say, mismatched types. Argument type does not match declared parameter type. Argument return type is add integer, but was expected to be integer. I feel like we should surround those in like quotes or backticks or something. That's much better. Argument type is add integer, but was expected to be integer. Perfect. And what if I think I should put like a new line at the beginning. Something like that. Well, I still want to see invalid argument. So we want to know which argument we're referring to, which is the address of B. We want to know which function we're calling, and argument return type is add integer, but it's expected to be integer. Perfect. I think that's a pretty good error, and a pretty good system to be able to print the type of things. That'll help a lot in debugging and just general error handling. What error are we getting now? Mismatched types, argument return type is add integer. So now if we go to here, oh yeah, we were testing, so obviously that should not be that. And it works. Look at us. Look at us. Very, very cool. So the entire type checker is different now. A lot of stuff has happened. And it now works on symbols. I don't know if you can hear, but I'm losing my voice. I'm definitely gonna have to go soon. One way or another. So when we create an integer, that's all fine and dandy. A variable access looks all fine and dandy. An address of, we should say ensure child is a variable access. Yes. Address of a dereference should cancel out. Maybe do this during parsing, right? Or just remove these nodes, pattern of nodes during optimization. I think that would be good. Or just remove, yeah, I think we'll do that. So we're using type check expression of the address of, we just add one pointer and direction level to the type. Negvorsa says, are there any reason for outputting error to standard out versus standard error? Is there any reason to print errors to standard error instead of standard out? I don't know. I've literally never used standard error. I know you can use like fair. Is that what it is? No, it's not fairer. It's like, I don't even know how to print to the error. You know what I mean? How do you print to standard error? I know I could use like standard error as a macro which contains the file descriptor, but I don't want to like use fprintf on standard error like this just to write an error. I don't see what the use is when I can just use printf and type error. You know? Negvorsa says fprintf standard error. Alright, so exactly what I was talking about. But yeah, why? Is there a reason? I don't see the reason. Is it like it's just you're supposed to? Is it just convention? I've never seen a difference. Does standard error get flushed more often? Or is it not buffered? I would understand that. But yeah, there's literally no reason. It's just that when I wrote this, I used printf. That's it. It would be really no different. We could just rep string, right? We could replace printf with fprintf, and it would be fine. Does it matter? I don't know if it matters. If it does matter, I'll change it. If there's a reason. Like, oh yeah, that makes sense. But if it's just like convention, then I don't know. People can see the errors either way. Nothing changes. Okie doke, okie doke. So dereference looks good. If, I'm pretty sure we wrote today, so this should be rather good. We can also use type compare symbol, I'm pretty sure. Alrighty. With that, we have a function, and we ensure that they match properly. We set the result type of a function properly. We update the context to enter, which we should also do an if. It should be like context entering and such. So we should have something like this. enter if then context. So we basically say, okay, yeah, to enter equals context to enter children. So now they get to enter and context to enter be referenced. You need and. So now when we type check an if, we should be able to enter its context. And this should say, basically, when if has otherwise, when if has otherwise, enter if otherwise context. And to do that, it's going to be a very similar thing, but first we have to update our context this way. So after we type check all of this, then we can eat the if-then context. I love eating. Negvorsa says, thanks, I learned a lot of thing today. I have to go and I will watch the rest of the video offline. Thank you so much, Negvorsa. I really appreciate you tuning in, and I'm glad that you could learn. It's so cool to be able to spread knowledge across the world. Thank you for watching. And good luck. Have a good day or night or whatever time it is for you, Negvorsa. Good luck on your journey. First time chat from a new viewer. How's it going, Deoxys? Sweet name. Hey, why can I play PS1 games on Windows computer? Why can you or can't you? It's because they're different CPUs, different machines. It'd be like asking, why can't this truck engine just like, why can't it be in a car? It's like, well, they're different sizes. They were made for different things by different people. They don't have the same anything. They're just different things. But if you mean, why can I play PS1 games on Windows computer? He says, I can, I want to know why. Okay, well that would be because people wrote an emulator for your CPU that intakes instructions that the PS1 would have taken in. So like, if the PS1 had an assembly that was like, load A41 into like the H register or whatever, or R42, this would be converted into assembly for x86-64, if that makes sense. So you'd say like, oh, we'll use the A register and say move 41 into racks. Does that make sense? So you kind of take in what the CPU would have done for the PS1 and you reverse engineer it and go, okay, we need to do that on our CPU. So how do we do that? And then anytime you're supposed to run the load A, then you go, oh, we have load A converted into these instructions. So then you just alter the executable or write a virtual machine that interprets this at runtime, and bada bing, bada boom, you can do it. But yeah, it's literally just writing a program that mimics a hardware CPU setup. That's why. Deoxys says, oh, hopefully that helps you, Deoxys. Hopefully that was informational. Informatical? Informative. There we go. Water. So good. In any case, we have to eat the if-then context. So then we have to enter the if-otherwise context, which should equal the next child. So everything here should be good, but we have to use context to enter and to enter. Right? And then we have to eat otherwise context. Upcase region. Eat if otherwise context. And this is going to say context to enter is equal to the next child. Deoxys says, when you do dereference, is that lambda notation? Oh lord. Deoxys, we're writing in pure C today. So what happens is, let me just do something for you. You can see that, like, we can have a function and we can create a pointer. So if we have an integer, right, an int, a, we can like say, oh, that's 42. But you can also create a pointer. It's not a pointer quite yet. I'll get to what it means. So then you can create a pointer to an integer, right, like this. And it can equal the address of a, let's say. So to access a, you would do a dereference of putter. And this would get you the value of a, an integer. So this is completely valid code. It's a dereference. But now imagine you have like some structure, complicated structure with like multiple things in it. And let's say that you have a pointer to one of these things through malloc, let's say, right? So you have some memory here. And you should check for null from malloc, but saying that. So now you have a foo pointer, and you could say foo a is equal to dereference putter, and then say a dot a is equal to whatever, right? But then you'd have to dereference putter again and say it equals a. So to avoid this whole thing, where you have to dereference, update the struct member, and dereference again, what you can do is use this fancy little operator that basically does this. It wraps your pointer, right, in a dereference, and then puts a dot there, and then it lets you access a. So this code, right, here, I'll just do it, is the same as this code. So a pointer can have to a structure. You can access the members of the structure through a dereference operator, which is that arrow. Deoxys says, oh, yeah, hopefully that helps. So this code and this code is the same, but this operator just dereferences the pointer, accesses the member, and updates it. And then it does this for you as well, where the actual memory address of A is taken from this structure. So it's kind of like a shortcut to more quickly deal with pointers to structures and things like that without having to deal with terrible, terrible things. And also we can no longer return something like this, but we could return pointer A. That is an integer. Alrighty, hopefully that helped. Deoxys, I love answering questions. If you enjoy what you're seeing, be sure to hit that follow button, check out the YouTube down below, subscribe, everything that you may want to do. And really, be sure to check out the Discord. We have a ton of fun, and we all help each other out with code review. We share our hobbies, like I like forging. We like pull requests for the compiler. Deoxys says, yeah, it did. Good explanation, actually. Thanks. Awesome. I'm so glad I could help. But yeah, our Discord's a ton of fun. There's notifications every time I go live, so you'll never miss another stream if you do not want to. Alrighty, let's keep it going. So we now are eating contexts. We can test that this works, I guess, by defining something here. So we'll create like C, which is an integer 42, and then return C. See, it's we got some sketch. Invalid AST context fed to CodeGen. Okay, so CodeGen said invalid AST context fed to CodeGen. It looks like it's right here. Could not find variable declaration in environment. So we have a variable declaration, and we're trying to get its type. So we're looking it up. And we're trying to look up in the variables environment, expression children, the get, which is the variable symbol C, and we look up in every single context up until the parent context. So if we never enter the if context, that would be an issue. So with if, we code-gen the expression, the conditional expression, and then we say, okay, here's the if condition. Then we generate the then expression body. So there should be to-do/fix-me. I don't have time today, but there should be context handling here. And also I'm going to go to to-do, make sure I don't forget this, and say, holy crap, we actually made great progress. I did not expect this. I thought it would take days, but the transition itself was quick. There are a lot of side effects from old code that used the nested children pointer style. But as we write more and more, and refactor and overhaul, things will fall into place. One thing that we are definitely not handling properly is contexts of if expressions during code gen. So can I make a link here? So generate then expression body, generate code to copy, blah, 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 generate otherwise. There should be more stuff here. And basically, one thing that we're definitely not handling properly is contexts of if expressions during code gen. So I would like to capture a link. Can I do that? Org store link. Okay, now I'd like to say, what is it? That's what it is. And this description is going to be code gen of if expressions. Perfect. So now I have a link that I can open, and it brings me right to my to-do fix me. And I'll probably just copy this into its own thing as well. Perfect. So now we changed the type system surrounding pointers entirely. It is now done completely new, which means we are done with today. We've done it. We did the 30th, I can't speak, the 30th of August. And now we want to say fix if context handling during code gen. And then we'll put this in there. And this is now. Deoxys says, wow, congrats. Thank you. It's exciting. So before Deoxys, we had, what do we have? We had this thing where we had a node, which is a pointer, which had a child, which was a pointer, which had a child, which was the symbol integer. And this is how @ integer was stored. And this is, I realized after working with it, it's just horrible. You have to do tree operations all the time and trying to okay, now this pointer is actually one less of a pointer, so the pointer here is actually equal to this one, but then this gets leaked, so then it's all sorts of memory issues, right? And it's just inefficient memory-wise and overcomplicates the issue, as I said right here. So now what we have is a symbol integer, which refers to our type name, right? And it has an indirection level of 2 because it's a pointer to an integer. So now, to check if two types are equivalent, we just compare this string and compare this number, and then we know. We don't have to do tree walking to ensure that they're the same structure. So this makes it much, much simpler. But I thought that conversion was going to take a long time, and it only took an hour, which is wonderful. And yeah, so now we just need to work on code gen of if statements so that stuff like this can work, where you define C within a local context. Because I'm pretty sure if I define it up here, everything would be fine. I don't know. Yeah, see, everything's fine. But as soon as we try and do something in the actual if statements, it goes, hey, 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 buddy, old pal, that do not work. Awesome. So let's do a git commit to commit there. Let's put this back as well. Okay, so what do we got in git to commit? We have type checking pretty much redone entirely, which is fair. We have parsing changed slightly to deal with pointers differently. And we haven't dealt with code gen basically at all yet. I mean, we did a little bit, but not a lot. Lambda Coder says, I see maggot. Ooh, Lambda Coder has fancy things. Frankerface Z supporter and Prime Gaming. Ooh, he got that Twitch flex on us. Yes, this is definitely maggot. We are in Emacs using the ultra, super amazing Git porcelain known as maggot. So we would like to say, yes, there should be context handling here. There's errors. We want to deal with pointers differently. Sure. Sure. So parser.c, we're going to take away that and add that. I don't think it has to be more complicated than that. We remove node type pointer because it's not a thing. Remove node type pointer because it's not a thing. Remove node type pointer because it's not a thing. And okay, we'll have to figure out what that is. Eternal Wild Fox says, at Lenser, the first part of the code works now, the backtracking. That's really cool. You're beginning your precedence parsing. That's so awesome. For those of you that don't know, Eternal Wild Fox is very active in our Discord and Twitch streams, and he's getting it working. Ooh, look. My code looks ahead and gets the correct operator with the number tokens. The start is there. So 1 plus 2 times 3 gets turned into token type integer 2, token type multiply times, and token type integer 3. Nice, so you're able to find the highest precedence operator now. Very cool, very cool. So now you're gonna get, nice. So now you're working on the backtracking to get the 1 plus after the higher precedence. I like it. Eternal Wild Fox says, yes. Yasu, kawaii freaking desu. That's very awesome, Eternal Wild Fox. That's so exciting to see your progress. Alrighty, so we also now parse types with indirection levels and not children, and we free the type symbol. We have comments. We definitely need that. Remove pointer type and such. I'm not even gonna go through all this, but this is type checking. We updated type checking. And now we can say we updated type checking. Type checker. This is really just overall, but type checker. Convert from nested child style pointers to indirection count. Ooh, it's red. It's too long. So we could say use indirection count instead of nested child style pointers. That's good enough for me. Woo! Hey, I think we got a... Hey, we did. Lambda Coder, it is so good to see you. Thank you for hopping in this server. Grammar to Parser Boy with the wave right away. So awesome. Thanks, Grammar. I love you for being an amazing part of this community. You're active with everybody. I want to thank Grammar to Parser Boy. He's awesome. And I'd like to thank everyone, of course. You are all awesome. But Grammar to Parser Boy consistently shows it. Perfect. That is now pushe pushe. That's on Git. It is there. It's not coming back. Perfect. So now if we refresh, much better. Much, much better. Looking pretty good. We have Clang GCC as an LD build examples now. And still just our little example, but we have more examples now, so it's better. You can see how pointers work. You can see how factorial works. It would be awesome to get our language in Linguist, Git Linguist, so that we could have stuff like that. Deoxys says, just import MyPy. Awesome. Lambda Coder says, nice, I just did that in my transpiler. I used look ahead instead of backtracking. Nice. It's there's so many ways to parse, it's amazing. Well, with that done, I think we have redone our entire type checker. We have done everything except update CodeGen. So our CodeGen now just needs to handle if and then contexts, and then we will be off to the races. We're gonna have a much better system now. This is so sweet. I would just like to thank everybody for watching. Deoxys with the follow, by the way, I completely missed it, but thank you, Deoxys. I very much appreciate the follow. I'm gonna go into my little end of the stream spiel here. I can't say that word. Because I've been streaming for 3.5 hours, it is nearly noon where I am, and I have to do something today, not just sit on my computer. I gotta get out there. So, I would like to thank everybody so much for watching. I'm gonna point you down below to the About section of Twitch, which has the Discord, where you can be like Lambda and join. Everybody can wave and say hi. You can see what everybody is working on. You can see PRs that are happening to the compiler. It's a lot of fun. Lambda Coder says, one day I'll show up before the end of the stream. And then he salutes. A Mario salute. Lamau. Don't... I hope so, Lambda Coder. It'd be nice to spend some time with you when I don't have to go right away. Maybe one day I'll do a late stream. I'll start streaming at like noon and do stuff in the morning. That sounds good. Meet some new people. But yeah, thank you so much. Be sure to join the Discord down below in the About section. And feel free to do it. Ask for help. As long as you're a friend and positive, there will be no issues. There is also the YouTube down below. I don't know if I have this ready, but if we go to YouTube, you can actually see that, I don't know what I'm gonna see because I'm not logged in. But if you look up the proper thing, hopefully it comes up. You can see my YouTube, lens_r, it's the same. I have all the compiler videos that you could ever imagine, all the way from part 1 to now part 23, which you're watching right now. How about that? There's also another series on suicidal AI, which is a lot of fun, and some visualization of the Git from my OS. And also Chillstream for working on the text editor. There's a lot. Be sure to check out the YouTube. It's a lot of fun, and I really recommend it. You can catch up on all sorts of things. Go and see how we implemented pointers in the completely wrong way a week ago, and how we re-implemented them today. But yeah, be sure to check out the GitHub link as well. Go and star and fork this compiler and all sorts of projects if you find them interesting. I have an OS, I have a text editor, I have another programming language, I have a bootloader for UEFI, I have this compiler we've been working on. There's so much. Be sure to check it out. It is all open source and for you to mess with. So I recommend doing that. With that done, I think I am... Lambda Coder says, glad I could join the Discord. Always looking for people to talk code with. That's awesome. We always love talking code. I am now on to my last thing in my little ad read. In the About section of Twitch, there is the PayPal donate button, and I would greatly appreciate any and all donations that come in. I don't have any other source of income, so it greatly helps, even if it's just $1. Plus, no matter how much you give, if you leave a message that is appropriate, I will read it on stream. And if you leave your name, I'll attribute it to you, as well as say the amount you donated. So thank you so much. Lambda Coder says a working unnamed language. I do that too. That's exactly what this is. It has no name. It's called Fun Compiler for now because we made it for fun. But yeah, we still got to name it. We have some ideas, but they're not top of the line or anything. Actually named the thing. Here it is. We have Funguage, we have Fun Language I made for Flim, Intercept, Simplex, Euclid, which we would just steal from the 70s. We have motherfucking pointers, or MFP. We have null-lang, none-lang, thing-lang, or the thing. We got simul, like simple or similar, I don't know. Naming things is hard. It is very hard. But yeah, we could, any of these are acceptable. I think they're all fine. But yeah, hopefully that works out. In any case, that's us done. We did it. Our compiler works when you don't feed it horrible code that I guess it doesn't work with if-else contexts yet. You can't define variables. But you can still call them, which generates a whole bunch of assembly, which really works. You can just use GCC, Clang, whatever you prefer. It's pretty simple. You just pass in the assembly file, and it generates an executable. And you can see shell command failed with code 8, because the greatest common denominator of 88 and 32 is 8. If we change it to 80, recompile, you can see that this is now 80 at the bottom here. And we can use GCC once more. And shell command failed with 16. Look at that. We got 16 and shell command failed with 8. Why is all this error messages? I don't know why all the error messages. But there, shell command failed with code 8, shell command failed with code 16. Greatest common denominator calculator. Fun. Lambda Coder says, I'm having that exact same problem as well. Gotta lift variable definitions outside of expressions into block level statements. That's one option, but we can't do that because ifs are actually expressions for us. So the return value of this this function is actually the return value of this if statement. So both branches of the if are required to return the same type. It's kind of like a mini function. So you couldn't do something like return, because if you can assign, right, is the idea, since it returns something. So you could say like a is an integer equal to, if a is less than b, then it should be like 42, right? Else it can be 0. You can do stuff like this, and it should work. So in our language, we need expressions to have, we basically need the if to have a nested scope. Otherwise, we're not really sure which context we're in. Like, has this been defined yet? So there's a lot going on, right? But yeah, we're working on it. We're working on it. Oh yeah, at the AST they're expressions, but when emitting, they turn to statements. I see. I don't do that. Mine still stay as expressions all the way through. Kind of like Clojure has to transpile to JavaScript to do just-in-time stuff. Yeah. I know what you're talking about. I know what you're talking about. But we definitely won't have to do that. We just create a scope. So whenever you create an if, this is actually another block expression, which will be in this block expression, and then this will have to be in that scope. As far as that goes, though, we're done with the stream for today. Thank you everybody so much for watching. Hey, my internet's going out right now. Perfect. Yeah, Lambda's Coder says, yeah, it's neat not to do that. It's not a simple transform, I'm finding out. Definitely not. My case is generating GPU code, no if expressions there. That's true. GPU code is very different from, you're doing like SIMD stuff, single instruction, multiple data, all the time. In any case, Lambda Coder, it was so great to see you. Thank you for coming out. Deoxys, I had a great time talking with you as well right at the end of the stream. Earlier in the stream, we had Grammar to Parser Boy being amazing. Neg Vorsa, Rohan, Nexovec. Who else did we have? We had Adderson28 we had in here. RPWH. Shout out RPWH, because he gave a donation today, the only donator for today. So thank you, RPWH. You are amazing, and we bow down to you for today. Tomorrow is a new day, and I may or may not see you then. Peace, everybody. Love you all. Bye-bye. Also, Lambda Coder said, great talk. Wish you a good day. I wish you a good day too, Lambda Coder. You're very positive. Thank you. Bye-bye.